Okay, hello everybody. Welcome to the fourth MTH 240 study session. Today we're going to do 4.3 differential equation, separable differential equations, and 4.5 linear differential equations. And I just realized something. I did not edit the scrolling text on the bottom of my thing, so hold on, give me 1 second. We're going from 6 to 8 p.m. Number 4. This definitely is worthwhile content. And the topics are separable differential equations and linear linear differential equations. Okay. Technically first order, but that's okay. And I do realize that the text says something wrong there still. Okay. There we go. Okay, so everybody can see, first of all, my screen. It worked, like the transition worked. Everybody's good? You can see my notes here?
Yeah, can see.
Okay, good. So I will quickly just go over what I wrote in the notes here. There's really pretty short notes on this stuff. The hardest part of these sections are really the word questions are the hardest part of these sections. So doing the actual, like, math is not too bad. So let's, well, usually, we'll see. So first of all, a differential equation is some sort of equation where you have to solve for the function. So just like, 2x plus 5 equals 3, you have to solve for x. There's another one where you have a different kind of equation where you have to solve for an actual function. Similar to how when you solve like x squared plus 2x plus 3 equals 0, you can't just solve for x, right? You have to use the quadratic formula, or you have to factor, you have to use some method. Similarly, you don't have powers of the function, but you have derivatives of the function in there. So maybe you have the second derivative of y plus the first derivative plus 2, equals something. So you can't just solve for the function, you have to use some sort of method. And so that's why differential equations are kind of hard to solve if you don't have a method. The solution to the differential equation is the function that satisfies it. So this is literally all I wrote for 4.3. So a differential equation is separable, okay, if it can be rearranged in this form. So you have the derivative of the function times some other function of x, okay, times another function of y. So just to be clear, this is a function of x. Y is a function of x. So we're trying to figure out what y is, really. That's what we're trying to solve for. We're trying to solve for y. And so you do that by doing this, right? By integrating 1 over the y function, dy, and integrating the f function, dx, and then rearrange for y, which sometimes is easier said than done. So I will get what's his lecture notes here. Should have had them ready, but I don't have them. Okay, I got them. So I will start with one that is not, like, I'll just start with some random one here, not the first one, because I feel like most of us are able to do it. This one's kind of long, but not because it's very hard. Okay, and then just to be another thing is that just like when you're integrating, you can have like a whole family of solutions, right? Because of that plus c. The exact same thing with differential equations. You can have a whole family of solutions. And so an initial value problem is one where you like zone in on one specific solution because it gives you a condition to start with, right? And so let's do one of those. So this is a separable differential equation, and it's going to be y prime equals y squared minus 1, 3x minus 2, y of 0 equals 4. Okay, so these are our two facts that we know. So this is the actual equation, and this is our initial value. And so the question is, solve this differential equation. Okay, find the function y that satisfies this. Well, we can see that this is in the form y prime equals, if I just move things around, f of x times g of y. So I can use the formula, which was integrate 1 over g of y dy, and equate that to f of x dx. So 1 over this, so integral 1 over 3x minus 2 d. Nope, sorry, wrong one. The y function, so y squared minus 1 dy equals the integral of f of x, which is 3x minus 2 dx. Okay, y squared minus 1, that's some of some kind of trig one, I think. Is it? No, maybe it's not. It's not a trig one, so we have to do partial fractions on it. Yes, we have to do partial fractions on that. And then this one is not too hard to integrate. So let's look at this left one here. We got to do partial fractions on it. So it's going to be the bottom factors into y plus 1, y minus 1. So I'll just separate that. Y plus 1, y minus 1 equals a over y plus 1 plus b over y minus 1. Okay, so 1 equals a y minus 1 plus b y plus 1. 1 equals a y minus a. Well, I could. Yeah. I'll just do it like this. It's fine. No, I'll do the quicker method for this one because it's quicker. So pick y equals 1. So this would be 1 equals b times 2, right? So b equals a half. And then I will also pick y equals a negative 1. So that's going to be 1 equals a times minus 2 plus 0. So a equals negative a half. Okay, we have our two solutions. So we can say that 1 over y squared minus 1 equals negative 1 over 2 y plus 1 plus 1 over 2 y minus 1. Y minus 1. So I can integrate this now, right? So the right side here, the left side, it was, I can factor out a half too, so 1 half is going to go here. Negative 1 over y plus 1 plus 1 over y minus 1 dy equals, integral of this is going to be 3 over 2x squared minus 2x. We don't have to worry about plus c because we still have an integral over here to do it. So then now I will take, I will integrate this. So 1 half.
Wait, I have a question.
Yep.
So like you said, we don't have to worry about plus c, but wouldn't we have like 2 plus c's on each side and then have to like take why do we have only 1? Why not 2?
Well, you can have a plus c here and a plus c here, right? Like, sure, call that one c1, c2, and then subtract c1 from both sides, right?
Yeah.
So this would cancel, and on this side now you have c2 minus c1.
So just not a constant.
Let's just call that c. That's what I'm gonna do once I integrate this.
So there are 2 of them. We just kind of ignore it.
Yeah, there can be as many of them as you want. It's any number, right? It's any constant. So,
okay, thank you.
Yeah, no problem. So here would be negative 1 half ln absolute value y plus 1 plus 1 half. In fact, I'll take the 1 half out. Oh no, I can't take the 1 half out. Yeah, I'll do this a little differently actually. 1 half negative ln absolute value y plus 1 plus ln absolute value y minus 1 equals 3 halves x squared minus 2x plus c. Okay, so now we do our solving for y, right? Because that's the whole point of this, is that now I have an equation with just y as a variable, not y prime or anything like that, just y as a variable. So now I try to solve for y. Again, easier said than done in a lot of cases. I'll start by multiplying both sides by 2. It's going to be negative, and I'll switch the position of these two. So ln y minus 1 minus ln y plus 1 equals 3x squared minus 4x plus c. Okay, and then I can use my ln rule, my logs rule, by turning this into ln absolute value y minus 1 over y plus 1 equals 3x squared minus 4x plus c. Okay, and then all we have left to do, well, I mean, the only thing we can do now is take e to the power of both sides. So e to the power of this will just be, actually just be absolute value, y minus 1 over y plus 1 equals e to the power of 3x squared minus 4x plus c, right? So the plus c here can be taken out, and it's as if you're multiplying by e to the c, right, by a different number. I'm going to move that to the front, e to the c, right? You can test your ability to do power rules. You can see that this is the same still. I didn't change anything here. E to the c. E to the c, again, is just some constant, some positive constant, right? And e to this should be also always positive. Yes, it should also be always positive. So, unless, yeah, I don't see why that would not be positive. So you can drop the absolute values. Okay. That part is always the most confusing for me. I agree. But yes. Wait, everything's good. I just want to see this. Oh, I see. Okay, so for the next part, just want to make sure I'm doing this right. Yeah, for the next part, we just multiply both sides by y plus 1. Y minus 1 equals y plus 1 e to the c e to the 3x squared minus 4x. Okay, so y minus 1 equals y times e to the c e to the 3x squared minus 4x plus e to the c e to the 3x squared minus 4x. You know, I should have done the c thing up here. Yeah, you know what? I think at this point, I'm going to use the initial value, because it's going to get more complicated after this. I'm going to use the initial value, which they gave us, y of 0 equals 4, to figure out what c actually has to be. And I'm going to do it here. I can do it at any step. So here is, I think, the best, because we have our c there. And it's kind of already rearranged. So y of 0 equals, what was it? 1? Oh, 4. Y of 0 equals 4. So it'll be 4 minus 1 over 4 plus 1 equals e to the c, and then it's 0 for all these exponents, right? So it's 3 times 0 minus 4 times 0, so that's just 1, right? So this is going to be 3 over 5 equals e to the c. And I don't even have to figure out what c is. E to the c is enough. We have an e to the c here, 2 cases. So wherever I see e to the c, I can just replace that with 3/5, right? So kind of a confusing thing I'm doing here, but just replacing it with 3/5. Right, I said e to the c was 3/5, so I can do that, right? Okay, so then now I'll just move the y terms to one side. So y minus minus 3/5 y e to the 3x squared minus 4x equals 3/5 e to the 3x squared minus 4x plus 1. Right? So notice there's no c here anymore, right? There's no arbitrary constant, because we've put in the initial value. So it can only be one function now, and we're solving for that one function. So y bracket 1 minus 3/5 e to the 3x squared minus 4x equals 3/5 e to the 3x squared minus 4x plus 1. So y equals 3/5 e to the 3x squared plus 4x plus 1 all over 1 minus 3/5 e to the 3x squared minus 4x. I was about to write plus c. That is incorrect. And then you can multiply by 5. Yeah, that would be the same thing. E to the 3x squared. Yeah, there you go. That's your answer to this differential equation. So that's the function. that when you plug it into this equation up here, right, it's true, and also this initial value is satisfied, right? So that was a good question, a long one, like relatively long, I think. So how do people feel about that one?
Could you scroll to the top a bit, like to the very beginning?
Mm-hmm.
But okay, so I remember like when looking through the notes, like wasn't the first step figuring out what y value and what x value make it 0 or something? Wasn't like a step?
What y value and x value make this function 0?
Yeah.
Not that.
Because I remember,
Yeah.
wasn't it like a step?
I don't think so. I have not done that unless I'm missing something, which is possible. Maybe.
Because like like maybe I looked at it wrong, but like when I did the homework for this, I remember like that was a step, and then I was like, but like what is it good for? So
Yeah,
maybe it's just my
it wouldn't be good for anything here.
yeah, I know that because I was thinking to like ask you, but maybe I just looked at it wrong or something because it was not good for anything.
Possibly, yeah.
If you can send the screenshots for like the slides in the chat.
If it's what you can send the screenshots.
Yeah, to like see what it means.
Sure.
Maybe it's like important for something.
And someone else asked something there.
Can you zoom out, please?
Zoom out, yes.
Thank you.
Like all the way. So can you see everything still? Might be too far.
Just scroll down a bit to the end.
Okay.
Thank you.
I'll go here a little bit.
If you just like speed run through this like the steps again. Well, not really all of it, just like the major parts.
Yeah,
Not
sure. Sure.
Yeah.
Sure. God, just take 1 second because someone needed to look here. Okay, so yeah, I'll go through what I did quickly. Okay, so this is our differential equation. So I noticed that it's separable. I can write it in this form. In fact, it already is in this form, right? Y prime equals f of x. This is f of x.
Okay, I sent it.
Okay, so
after
I'll take a look in a minute. Okay. So this is f of x. This is g of y. So I can write it in that form. So based on this, we have a formula for it, and we can write it like this. So I just do that. G of y was y squared minus 1, so 1 over y squared minus 1 dy. And then f of x was 3x minus 2, so 3x minus 2 dx. Okay. This one we need partial fractions for, so I do the partial fractions. That's this part. That's just partial fractions. Right. And then here I do the actual integration, so I integrate the right side, and then I factor out the 1/2, and I have the whole this side, which is just a bunch of lns, right? Multiply both sides by 2, rearrange, use a ln rule here, right, to put them on top of each other, and then e to the both sides. So e to the left side gives me the absolute value of y minus 1 over y plus 1, absolute values, and on the right side we have e to the 3x squared minus 4x plus c, which I can move that plus c to the side as a multiplying by e to the c, based on our power rules, right? E to the c is a positive number. E to the 3x squared minus 4x is also a positive number, so absolute values do nothing, right? So the absolute values are meaningless, right? They don't do anything. So I can drop the absolute values. It's at this point that I apply the initial value. So, all these equations are equal. I mean, they're all part of the solution. So at any point I can apply this. So y of 0 equals 4. So and when x is 0, so this whole exponent is 1 here. The whole exponent is 0, so e to the 0 is 1. Should be 4. So 4 minus 1, 4 plus 1, because of y minus 1, y plus 1, gives me 3/5 equals e to the c. I don't have to solve for c, I can just solve for e to the c because that's what I have. So I can just replace everywhere that I see. Technically this should also be 3/5 there. So 3/5 there, and then so e to the c gets all replaced like that. And from here I just rearrange for y, which is kind of messy to look at, but is what's happening. Right. Okay, and then so yeah, I see the thing separation of variables. Check for values of y that make y of g of y equals 0.
Yeah, like, first, what's that good for?
I have no idea. I've not seen that.
Because like it's their court's notes, and I always wanted to ask like, what's that good for? Like, because they didn't have me solve it,
I got no idea.
so just ignore it.
Yeah, I would just ignore it. Yeah. Okay, so let's move on. I say hesitantly, let's move on to word problems. Although I don't know if we're gonna have a word problem tomorrow. Does anyone have any idea about that? Did anyone hear their professor talk about if we're gonna have a word problem for the test or not?
One prof said that there won't be word problems for tests, but this lesson's like half of it is about word problems,
Yeah.
so we will still get it.
So this prof said in general there's no word problems, but then nothing about this.
Yeah, but we don't really know, with Horowitz.
Yeah,
Like,
okay, we'll see. We'll see. Yeah. So, okay, then let's spend some time doing word problems, I guess.
Yeah, like whatever Horowitz says, you just have to take the opposite, to be honest.
I guess so. Yeah, there you go. Maybe that's what you need to do. So, okay. I have some of Horowitz's word problems here, so let's give it a try, I guess. They don't all, like... Okay, let's just give it a try, and let's see if we can make sense of it together. Because I've written them down, but who knows if they make sense. So here, I'm gonna type it. So, okay, start with 3 kilograms of salt in 75 liters of water. Okay, a solution is poured in with 0.4 kilograms per liter. With a concentration of 0.4 kilograms per liter at a rate of 6 liters per minute. Okay. The mixed product is drained at the same rate. Okay. Question is find f or just find a function. Find a function which represents the total salt concentration at time t. Okay, that's the question. I will have to refer to the notes a lot for this question because the word questions can be tricky. Of course, I'll try without it, but let me make the words bigger. There. Okay, so there's our question. Start with that much. We have that much water in a big thing. Sorry, we have that much salt in a big thing. We have a new solution that's poured in with that much, and at a rate of 6 liters per minute, the mixed product is drained at the same rate. Okay, so find a function which represents the total salt concentration at time t. So at all times, something we know at all times is that V of t equals 75 liters, right? We also know that the concentration, which I'll say is a function s of 0 equals 3 kilograms, right? So if we say s is concentration, right? I should say s of t is the concentration as a function of time, right? T is the time and V is volume. Okay, that's all we need to do.
Wouldn't S of t be the salt content?
Yes, it would be the salt content. Exactly. It would be mass of salt. That's what it would be. Yes. So from here, yes. Now this is the main part of solving this, and this is what I have to look at the notes for, and after this it's not too bad, is that S prime of t is the inflow minus the outflow. Right? I suppose in mass, let me think for a second here. 0.4. Yeah. Yeah. Okay. Yeah. So the amount of mass that's flowing in, right? Mass flowing, mass flowing in, and this is mass flowing out, right? Which, okay, yeah, as a function of time. Yeah, okay, that makes sense. Something about it doesn't make sense. It seems like it's too simple, honestly, in my head. But sure, the rate of change of the mass that's in there is the amount going in, the difference between the amount going in and the amount coming out. Because if those are equal, right, then the rate of change is 0. If the same amount of mass is coming in as is leaving, the rate of change is 0. Okay. And if there's more coming in than leaving, right, then the rate of change is positive. Yeah, that checks out logic, right? So, okay. Now we just have to find these things as functions of time, right? So the inflow as a function of time. Well, for a function of time, we have the inflow is how many, what did we say was up here? We said that it was 0.4 kilograms per liter at a rate of 4 liters per minute, right? So if I multiply these together, right, we get 0.4 kilograms per minute, right? So I guess I would write that as 0.4. No, I don't write that as that. I guess the inflow is not a function of time. That's what this is. But at time t...
No, the inflow would be 2.4 kilograms times t, where t is
0.4 kilograms. Yeah.
2.4.
Why 2.4?
Because it's 6 liters per minute.
Oh,
so
times
6 liters
times
per
0.4? Yeah.
Yeah.
So that makes sense. 0.4 times 6. Okay, so 0.4 times 6, and I'll write the units here so you can see. So kilograms per liter, 6 liters per minute, right? So we have this. Again, this is the inflow. This is how much is coming in, right? So yeah, that'll cancel, and we just have kilograms per minute is all that's left, right? So I'll write that here. I'll actually erase everything. So 0.4 times 6 kilograms per minute. And that's what we want. But shouldn't that be times t is my question here, because we want concentration.
Yeah, it is.
In my notes, it's not times t. It's a constant.
Oh, yeah, it is.
It's a constant.
times
Doesn't
t,
it
but
come
it's a
in a
constant.
constant rate? It's a constant.
I think it should be at times t. That's what I would say.
No. I don't think it's a times t because, like, if you think about it, it doesn't come in faster as time goes on. It comes in always at
Okay.
wherever.
Yeah.
That's true. That's true.
That's true. Yeah, that's true.
So it's just whatever that is kilograms per minute, and that's all the time. Like it doesn't change.
I guess it's in flow. It's not like mass coming in. It's the flow coming in, which is going to be a kilogram per minute. Okay.
Yes.
That makes sense. Okay, sure. So leave like that.
And the outflow, I'm guessing it depends on t.
Yeah.
Yeah, I'm guessing.
Right. So that depends on depends on the
Concentration.
Similarly, yeah, we say the concentration at time t, right? Times is again 6 liters per minute. 6 liters per minute, right? So this is going to be in kilograms per liter, right? So I can write concentration at time t as the mass at time t divided by the volume at time t, right? So S prime of t equals, now this was 2.4 minus S of t over V of t we know is always 75, right? Times 6 liters per minute. Right, so here we have a differential equation, right? I'm going to write this one as a fraction just so it's a little easier to work with. So this is 2.4 is 12 over 5, 12 over 5, minus, and I'll write this as 6 over 75 S of t. Not S of negative t, S of t. Right, so here, let me recap that because that's like the hardest part. So we know that the derivative, the rate of change of the mass is the inflow minus the outflow. Okay, so the inflow, how much mass is coming in per minute, right, is going to be the concentration of the stuff coming in, 0.4 kilograms per liter, and how many liters per minute, right? Times that, multiply these two. And that's going to get you kilograms per minute, which is what we want. We want the rate of change of mass, right, per minute. And then similarly here, the outflow is going to be a very similar thing. Here we know the concentration coming in is 0.4 kilograms per liter, and we know the rate that it's coming in at. For the outflow, we know the rate that it's leaving at. We don't know the rate that it's entering at, though, right? We only know the rate that it's entering at is S of T, right, which is the mass of salt divided by the volume. That's what concentration is, right? Mass divided by volume. So we do that, mass divided by volume. Volume's a constant. It's 75 always, right? So then I can just rearrange and get it into this form like this, right? And I'll write this as just S instead of S of T.
So the inflow minus outflow, is that supposed to be just memorized, or are you supposed to like arrive to that on your own during the test, hypothetically speaking?
You're probably just supposed to think about that on your own during the test. That's what's supposed to happen, yes. But it's a good thing to know for any kind of problem like this, right? Yeah, so S prime of T is inflow minus outflow. And I'm sure that can apply to lots of other kind of questions. So from here on, we can just solve this as a, what's it called? Separable differential equation, right? We have something in the form, I'll say y prime equals f of x, g of y, right? So our f of x, I could factor something out here, and I think I will. What did he factor out? He factored out a 2 over 25. Oh, because this is actually 2 over 25. 2 over 25. He factored out a 2 over 25, and apparently that worked. So I will do that, although it doesn't really matter. So S prime equals 2 over 25, and this was just 30 minus S. Right? Okay, so then from here, it's just a separable differential equation. Our f of x is 2 over 25. And our g of y is 30 minus s. So technically g of s. Right? And technically this is f of t. But yeah. Right, just to match the variables. But so what you're looking for is some function of this variable, right, times a function of some other variable. Or no variable is fine. Whatever. Right? Just of just a number. We could have done this before and just said 1, and then that would work too. So to integrate this, it's going to be integral of 1 over 30 minus s dy equals integral of 2 over 25 dx. Right? So this is going to be negative ln absolute value 30 minus s equals 2 over, let's say 2 over 25 x plus c. Right? I'm going to multiply both sides by -1, so 30 minus s equals negative 2 over 25x plus c. Okay, now e to the power of both sides is going to be absolute value 30 minus s equals e to the negative 2 over 25x plus c. I can move that c can come out as another thing, so it's going to be absolute value 30 minus 5 equals e to the c, e to the negative 2 over 25x. Okay. Well, can e to the x is never negative, right? E to the x, it doesn't matter, right? So it's never negative. So positive number, e to the c is always a positive number. So we can just replace this with no absolute value and just solve for s now. Right, so it's going to be 30 minus e to the c, e to the negative 2 over 25, I'll write that nicer, negative 2 over 25x equals s. And now we have an initial value of s of 0 equals 3. S of 0 equals 3. So I'm going to plug that in. S of 0 is going to be 30 minus e to the c, e to the 0 equals 3. E to the 0 is 1, right? So 30 minus 3 equals e to the c. So 27 equals e to the c. to the c.
Sorry, what was the integration factor that we got?
Like integration factor or the integral that we did?
So like you had s prime plus 6 over 75 or 2 over 25. S of t is equal to 2.4, right? Didn't we have that at some point?
No, I don't think
Yeah,
so. Wait.
Yeah,
wait.
yeah, it's right there. It's right there. Yeah, you have s prime is equal to 2.4 minus 6 over 75 s of t.
This
Yeah,
here.
exactly.
Yes, that line there. Okay, yes.
So then how did you determine what you were going to integrate there, and like what with respect to what?
Well, one has to be a function of this variable. One thing has to be a function of this variable. So I factored something out just so it's a little simpler. So one of the things, again, has to be a function of this variable, this s here. So here's a function of that variable, right? And then the other thing is just a function of the thing that this is a function of, right? So it's kind of a weird way to say it, but
like dy over dx, where it's
right,
dx.
yeah, right. So this s is a function of time. So I just choose this constant out here to be the function of time.
Right, and then the integral of that would be 2 over 25 at.
Yeah, it would be integral of 2 over 25. Yeah, here I have it.
Okay.
Right, so it's
On the left side, that's supposed to be ds, right?
yes.
1 over 30 minus s.
Oh
ds,
no, that's sorry. That's supposed to be t here.
t, and then the left should be ds.
Yes, it should be ds. You're right. Yes. Yes, I did completely the wrong variables for both sides there. Yes.
Wait, so
Okay.
all of the x's are supposed to be d's?
Yes.
Yes. All the
I have a
x's
question.
all the x's are supposed to be t's. So I will go fix that.
Is there a reason why ln is negative?
Yes, I'll explain in 1 second.
Okay.
There we go.
The only thing is, isn't this s with respect to t, like, is s of t, isn't that mass of solid? So like ds dt, that's just rate of solid. I don't like that's the final the function doesn't make any sense. It's
This
not
here, this up here.
no. All right, you see how the last bit the question asks for concentration, like with respect to time.
Yeah. Find the total. This isn't the answer yet. This function s will not get us the answer. Sorry, I should mention that. We're looking for concentration as a function of time. So to do that, we need the salt content as a function of time divided by 75.
It's like,
75 is the
That's like,
which is mass.
All right, I think that makes a bit more sense because I was kind of confused. I was like S of t. That's not the
S of t is not the concentration. S of t
Yeah.
divided by 75 is the concentration.
Yeah.
And yet I'll explain the ln here quickly. So ds, right? So the reason I can do this quickly in my head is because if this was s minus 30, then it would be positive ln absolute value s minus 30, right? But I can see this the other way around, right? So it's 30 minus s. So right away, since I know that the variable is negative, it's going to be a negative here. But let me explain actually why that is, not just that it's something to memorize. So whenever you do an integration like this with the 1 over something and you do the ln of it, you're really doing a u sub. So u equals 30 minus s, du equals negative ds, right? So negative integral 1 over u du equals negative ln absolute value u, which equals negative ln 30 minus s plus c. Does that make sense?
Yeah, that makes sense because I thought you're just taking out the negative from the s, making it positive, but that would make the 30 negative. But no, that makes more sense.
So this is what's happening here. Yeah, this is what's happening. It's just because it's a u sub and it turns negative after that. Okay, I'm not quite done yet. So we found e to the c. Where was our function? I lost the function now. Here's our function. So this is going to be 30 minus 27 e to the negative 2 over 25 t equals s. And now equals s of t, really, I should just call it. Okay, now we want the concentration. So concentration equals s of t over 75, right? Which is just going to be 1 over 75 times 30 minus 27e to the negative 2 over 25t, close bracket. Yes. There we go. No plus c.
Y over 1 over 75, because this is 75 a concentrate.
Yeah, 75 is the volume. So the concentration is mass divided by volume, right? This is a function of time that's called for. This is a constant. It's 75.
Okay. Because I thought it was yeah, I get it. Thank you.
Yeah. Okay. Good.
Yeah. Just to put it visually though, S of E, and you just divided the mass over the volume. That's kind of concentration over T now, like the rate.
It's concentration. The concentration of T.
Yeah.
As a function.
Yeah. Yeah. Okay.
Right. Yeah. So because concentration by definition is mass divided by volume, so mass at time t is S of T, volume at time t is 75.
Yeah.
Right.
It makes sense.
Could you explain where you get the E of C? I see where you get the 3, but like, how do you know that like you use the 3 in that equation? Like 30 minus E of C equal to 3.
Well, so I take this, right? I take this here. So I'll write it right on the side here. So 30 minus e to the c, e to the negative 2 over 25 t equals S of t, right? So it's, again, we're putting in the initial value was S of 0 equals 3 kilograms, right? Because initially at time 0, you say start with 3 kilograms of water. Sorry, 3 kilograms of salt in 75 liters of water, right? So we know that S of, I'll do it in blue again, S of 0 should be 3, right? So that means that here t equals 0 and S equals 3. That's what that's saying. T equals 0, S equals 3. So you can even get rid of that. T equals 0, S equals 3. So 30 minus e to the c, e to the negative 2 over 25 times 0 equals 3. This is e to the 0, which is just 1. So it's 30 minus e to the c equals 3. And then we continue from there.
Okay, thank you. That makes more sense.
Okay. Good.
Yep.
Yeah. Okay, and there's our answer. And I hope that's right. Let's see. Well, he does some simplifying fractions, but yes, it looks right to me. Yeah. That's right. Okay, so there's our word problem. They are confusing. Let's try another one maybe. I have a heat one. And from there, maybe we'll look at chat questions after that. Any of the separable ones, we'll look at chat questions. So unless anyone has any questions about this one, I'm going to move on to a heat one. So I give you all a second to.
So it's still not really clear. Like, okay, we have mass as a function of time, but then just dividing that by volume gives us concentration as a function of time.
Yeah. Because if you choose any one time, say, oh, I want the concentration at 5 seconds. Well, to figure that out, you need to figure out what's the mass at 5 seconds. Well, that's S of T, right? And then divide that by the volume at 5 seconds. That's always 75, so divide it by 75. So whatever that concentration is at 5, right, at T equals 5.
Same, the volume is going to be related to that.
The what?
I don't know, if you just, I'm saying that the concentration will be related to the mass of time over the volume.
Yeah.
Okay. I think it's so simple, I'm kind of like, is it right? Yeah.
Yeah,
right,
I know what you mean. That's what I feel about this up here. This S prime of T equals inflow minus outflow. That doesn't pop in my head that this would be what it is, but it does make sense looking at it. So hopefully that's just knowing that is enough. Okay, let's move on to the next one. I'll have to type it again. So for our next question is, I really didn't write this one properly. I just did like the notes of the important numbers. So, okay, take cake out of the oven at 450 450. I don't know how to write degrees. 450 Fahrenheit. I'll just write that.
Okay, one thing how to spell it, but it's fine.
The what? Sorry.
I'm gonna hatch out with the spelling, but it's whatever.
Oh, did I spell something wrong?
No, it's fine.
Okay.
No, you said you don't have degrees, so I want to happy, but it's fine.
Oh, okay. The outside of the oven is 70 degrees Fahrenheit. Okay, then 10 minutes later, the cake is at 430 degrees Fahrenheit. Okay, how long will it take for the cake to reach 75 degrees Fahrenheit? Okay. Make that bigger again. So there's our question. That should be a question mark at the end. So the main trick of this, again, the main trick of this question is you have to know how to find this differential equation, how to write this as a differential equation, right? So this, and I can't exactly explain why, but this is written as the derivative of temperature with respect to time. So notice big T is temperature, little t is time, is equal to K times T minus the outside temperature. So K minus T, and I'll write this as I'll write it as T naught, so you can see it like that, right? Where T naught is outside temperature. Okay, and K is just some sort of constant. Let me write this. Yeah, K is just some constant. This is some kind of cooling law, I think, of something that wasn't explained to us, so I think it's just an equation to know. The derivative of temperature with respect to time of a thing like this is equal to some constant times the temperature minus the outside air temperature. It'd be nice to see some sort of explanation for this. I don't really know, but okay, we'll go with it. So in this specific case, I'm going to write it as T prime equals KT minus 70. Right? KT minus 70. And so from here, hold on, someone sent me. Okay. So from here, T prime equals this. So this is a separable differential equation. Our F of T is going to just be K, and our G of big T is going to be T minus 70, right? Yep. So this is going to integrate like this. Integral of 1 over T minus 70 dt equals integral of K dt, but pay attention to which T's I'm using here. This is going to be ln absolute value T minus 70 equals KT plus C. And so our goal now is to solve for temperature as a function of time, right? So solve for big T. So it's going to be e to the power of both sides. So absolute value of T minus 70 equals e to the KT plus C. Absolute value of this minus T minus 70 equals e to the C, e to the KT. Do we have an initial condition? Yes, we do. So at time t equals 0, the temperature is we have two conditions. Maybe that's to solve for K? That might be to solve for K. Yeah, okay. At t equals 0, the temperature is 450. And then at t, that's okay. At t equals 10, the temperature is 430. Both of these things are important because we have two variables to solve for. We have K and C here, right? Or e to the C. So I'm actually going to, at this step right here, I'm going to solve for C. Okay, I'm going to do that by putting in the point 0, 450, right? At time equals 0, t equals 0, the temperature was 450. The reason I can do that here is because K is going to disappear with that. So it's going to be ln absolute value t minus 70. So 450 minus 70 is 380, right? Yeah. Absolute value doesn't matter anymore because it's a positive number. equals c. Okay, so I solve for c. I know what c is now, using that first point. And then, so e to the ln 380 is going to be just 380. So I'll just put that here. It's just going to be 380. There you go. Okay, so now we want to, again, just keep solving for t as a function of t, or t as temperature as a function of time. So this is always going to be positive. This is always positive. So you can just get rid of the absolute values. And t equals 380 e to the kt plus 70. And there is our function of time. Now we just have to figure out what k is, because technically t is a function right now of k and t. So k we can figure out by putting in another value that we know, which was at 10 minutes. Right, at 10 minutes. Someone say something there? I think I'm good. At 10 minutes, we were at 430 degrees. Right, so so 430 equals 380 e to the k times 10 plus 70, and now we just solve for k. Right, we solve for k. So move 70 over, subtract 70 from both sides, so it's going to be 430 minus 70 over 380 equals e to the 10k. 10k. This is 560. Yes, 360. I mean, sorry. 360 over 380 equals e to the 10k. So 36 over 38, which is 18 over 19. 18 over 19 equals e to the 10k. Okay, so ln of 18 over 19 equals 10k, and divide by 10. So 1/10 that. Let's see if that's what he got here too. 1/10 ln 18 over 19. Yep, that's k. So finally, we can take this equation here. We can take this equation here, and our final answer for the function, which not the final answer for the question, but for the final answer of the function, we know that t equals 380 e to the power of, I guess, hold on, I can do something with the lns here, can't I? It's going to be, no, I can't. Oh yeah, I can. It'll be
yeah. Okay,
18 over 19 to the power of t over 10 plus 70. I can check the answer here. It's okay. It's not a big deal. Yeah, that is right. That is right. Okay, so there is our function. There is our function t of t. Right, temperature as a function of time. Now, the question asked, how long will it take for the cake to reach 75 degrees Fahrenheit? Well, it's pretty simple from here. Right, so 75 equals 380, 18 over 19, t over 10 plus 70. So 5 equals 380, 18 over 19, t over 10. 5 over 380 equals 18 over 19, t to the 10. I can... how did he do it here? Did he take a weird ln base? Yeah, I can just... I assume that's 1 over...
Yeah, you just do log of base 18
yeah,
over...
I'll do that, I guess.
Nah, that's like the best way to do it, to be honest.
T1, I'm just trying to see how he did it here. 1 ln... Oh, yeah. Well, yeah. Okay, I'm gonna take the log... It's kind of a stupid way of doing it, but log base 18 over 19. Not saying to whoever suggested that a stupid way. That's what I was gonna do too, but it's kind of a poor way to really execute it. Like it's written weird, but that's okay. Not everybody's calculator can do it too. So there we go. There's that. So 10 times log base 18 over 19, 5 over 380 equals t. Okay, and now let's figure out what that is. 10 times log base 18 over 19, 18 over 19, 5 over 380. So I got 800 seconds. Is that the right answer? Yeah. I'm just going to check here because I didn't write the exact answer for his answer here, but 10 it's also in lawns, so it's a little harder to see, but 18 minus ln 19. Yes, 800 seconds. That's right. 800 seconds. And the question was, yeah. It'll take 800 seconds for it to reach this temperature.
Well, I got 801, but it might just be like some error.
It's just how I'm rounding it. Yeah, I just rounded it wrong. It's 801. Yeah. That's right. Okay, and I'll just be clear here. This is seconds, not times 5 or 8,015. So, okay. How does everybody feel about this question here? Really, the main trick is knowing this thing here. That's the main trick, is knowing that.
Yeah, I think it's like every other question. It's just like you need to know that one formula.
Yeah. It really is. Sorry, it's this up here, not that. Right, but yeah. Right, so if you have a temperature kind of question, this is going to be useful. dt by dt equals k t minus t.
Yeah. One thing though, you see that part where you had the constant and then change it to the value raised to the like log of x with like y in front of it, and you raised it to like log of x and y. How did you get rid of the natural log? Did you take e on both sides afterwards?
Where here? Looking at here? Or what am I looking at?
No. I think it was further down, like closer to the answer actually, where you like 18 over 19.
Yeah, solving for k here.
Was it? Yeah.
This section here. So, and what part do you want me to explain?
Like when the rule is like if there's a constant in front of like a log, you can change it to a log of the like x risen to the power, right?
Yeah.
So that's what you did. Because like I think you may have skipped a step because I just saw you move from that to just the x risen to the constant. I was just like, how do you get rid of the log right there? So just checking it.
Wait, is it on the screen right now that I'm looking at, or? Oh,
No,
here.
maybe.
This part.
Yeah.
This part here, where I only have log on
Yeah.
one side here.
Yeah.
Yeah. Well, all it is that ln e to the 10k. Yeah, ln e to the 10k is 10k ln e, which is 10k. Ln e is 1.
Yeah.
That's all it is. Right. So that's to get there to there.
Yeah.
And so then I just divided by 10 to get
Yeah.
to get rid of the 10.
Thanks.
Yeah, no problem. Okay, so there's that. Then this this is the last word question I have for this section. And also someone messaged me and said, Majed said that the professor said there would be no application-based questions. So yeah, I've heard some people say there are no application-based questions. So I don't know how long we should spend on that because I don't know for sure. So I guess we shouldn't spend very long.
Yeah, let's just move on because like if the professor said there will be no application-based question, then I don't think there will be any.
So someone did send me a question. So by the way, anybody watching can send me their suggested practice problems or suggested anything to do. Just DM it to me.
Let's 3.7 questions.
You have 3.7 questions?
No, I'm saying let's do some.
Some 3.7. You want more practice of 3.7?
Wasn't it 3. Oh, no, I mean 4.5.
4.5. Yeah. Okay. Yeah. We will do that. I have one more separable differential equation here that I want.
Okay, great.
Someone sent it to me in the chat, so this is going to be a chat question. Right. Okay, so for here, This one is y prime equals e to the y 5 to the x. And we have an initial condition of y of 0 equals ln of ln 5. So let's give it a try, I guess. This will be our f of x is 5 to the x, and our g of y is e to the y. So integral of e to the negative y dy equals integral of 5 to the x dx. Hope everybody's good with this. If not, let me know. Negative e to the negative y equals ln 5, 1 over ln 5. 5 to the x. Yep, 1 over ln 5, 5 to the x. Yeah, because that makes sense.
dy over dx.
What'd you say, sorry? Oh, I think someone has their mic unmuted. And then now I want to rearrange for y, right? So it's going to be e to the negative y equals negative, I'll write it as 5 to the x over ln 5 plus c. Now I'm going to take ln of both sides, so it's going to be negative y equals ln of negative 5 to the x over ln 5 plus c. Okay. So now, and I can just move the negative sign to the other side. Okay, there's our function. And okay, let's just give this a try and see what happens. So y of 0 equals ln of ln 5. So ln of 5 equals negative ln of. So this is going to be, this is going to be, was y of 0. So negative 1 over ln 5 plus c. So solve for c now. I will do this by, could move it to the other side. I think I'll try that. I'm going to move both of them. I'm going to move both of them over. Or I could do over. I'm going to move both of them over. So ln, or move both of them to the same side, plus ln of negative 1 over ln 5 plus c equals 0. Log rules now. This is going to be ln of ln 5, negative ln 5 over ln 5 plus ln 5, or c ln 5, equals 0. This is just 1, of course. Now, e to the power of both sides is going to be negative 1 plus c ln 5 equals e to the 0 is 1. Add 1 on both sides is going to be c ln 5 equals 2. C equals 2 over ln 5. And I think that's right. So then we can take our function, which is here, and just put that value in for c. So y equals negative ln negative 5 to the x over ln 5 plus 2 over ln 5, which you can combine into a single fraction. 2 minus 5 to the x over ln 5. And that is my answer. I don't know if this is the answer in the book, but hopefully the person who sent it to me, if they're here, could check for me. And yeah, it's number, okay. If it's from the textbook, actually, I can just check.
Could you scroll down a bit? Oh, this is the bottom of the answer. Thank you.
No problem. Okay, so I think after this, oh yeah, someone have a question?
Yeah, sorry. Can you show the integral of the 1 over 5 to the x again? Because I have it standard.
Yeah, here. There, that's this.
Oh, it wasn't initially 1 over 5.
1 over
initially 1 over. Yeah. Yeah, no. Sorry, I thought it was initially 1 over 5 to the x.
Yeah, no. 1. Yeah. Okay. So, any questions about this one? but it's a good one. It's a good one. Let's see if I can see any complicated ones. Last complicated one from Horowitz's lectures, and then we can move on from that. Well, yeah, there's one that's pretty complicated.
Could you scroll down a bit, please? I want to take a screenshot.
Well, this will all be posted after, but of course, take a
Thank you.
no problem. Okay, let's do this one. Oh, you know what? This isn't actually that complicated. What, something that confuses me is that a lot is when I'm allowed to drop the absolute values, right? Because when everything's an exponent in the power of e, when everything's in the, so far everything's been like, actually, never mind. I don't know what I'm talking about. Since everything's e, in fact, I think that'll almost always apply. So like in all these situations, right, you do get an absolute value out of the ln, but since it's e to some power, you can just drop the absolute value. E to some power is always positive. So, okay, yep. Makes sense? I mean, okay, never mind. I was going to say any exponential function is always positive. Of course, lots of asterisks on that, but yeah, if you have like 2 to the 5, or 2 to the x, that's also always positive. Okay, so let's take a look. Yeah, I don't really have a harder one. They're not actually that hard when you... I have one here that makes us do integration by parts, so maybe should I do that? But I'm really going to spend most of the time doing integration by parts. Like, it's a pretty big answer, but kind of just the algebra of it.
It's integration.
Can you say that again? What'd you say?
I think doing like a question that's just long version of integration.
You want to do that or don't want to do that?
No, I don't think we should. Because it's just a simple thing, and then the long part is just an integration by parts.
Yeah.
Which, I mean, you could do that.
Okay, so yeah, I don't really have harder ones. I have one that gets okay. Let's do this one last one. It gets you to use a tan, but that's about it. So last one here for separable ones. Of course, if anyone wants to suggest problems, we can suggest problems. Oh yeah, and then hold on, someone else sent me some work here too. Was any of them? Yeah. So y prime equals 3x squared y squared plus 4. So our f of x is 3x squared. Our g of y is y squared plus 4. It's going to be integral of 1 over y squared plus 4 dy equals the integral of 3x squared dx. So this is 1/2 tan inverse of y over 2, I think. Yep. And this is equal to add 1 to the exponent divided by that, so it's just x cubed plus c. Multiply both sides by 2, so tan inverse of y over 2 equals 2x cubed plus c. Right. Tan of both sides. So, do we have an initial value? Yes, we do have an initial value. Y of 0 equals 0. So, yeah. So, I can plug that in now. So tan inverse of 0 equals 0 plus c. Yep. So 0 equals c. So I can keep going from here, really, right? So tan inverse of y over 2 equals 2x cubed. So y over 2 equals tan of 2x cubed. So y equals 2 tan of 2x cubed. And there you go. 2 tan of 2x cubed. And technically, there has to be restriction on 2x cubed. But that doesn't really matter. It's okay. Okay, so that's the last question for separable ones. I'll move on to linear differential equations, which are a little bit more complicated to solve, although not too much. And yeah, definitely if you have any hard questions. I can also do the lab questions, which seem to be tricky, although, I mean, your lab TA has done them, so maybe it's not really worth the time. But does anybody want me to do the lab questions? Maybe can I get anybody?
Yeah, one, I guess, if you want.
Yeah, if you're like questions to answer, then we can do another question. I think number 4 was kind of tricky.
Okay, so yeah,
think
we'll
I
do
would
some
add
hard
one.
ones from there. Yeah.
Yeah.
So first, let me just go over linear. So we're on 4.5 now, and so let me take a sip of my water. 4.5 now, which is linear differential equations. Okay, so all it is it's just a differential equation that can be written in this form. So the derivative plus some function of x times y equals some function of x. Right? And notably, the coefficient here has to be 1 on that y. So if it's not, you just divide out. Right? So really, you can skip all this. That's the solution. Right? That's just a formula for the solution. Right? So if you have this differential equation, that's its solution. Now, how do we get to that? That's another story. Right? So you have something called an integrating factor, which is not just used in linear differential equations. It's used in a bunch of differential equations. And it's just something that helps you integrate. So in this specific case, for linear differential equations, it's this. E to the integral p of x. The reason that's useful is because we start with something like this, right? And in fact, I'll do this on screen. I'll actually write this. So 4.5. This is useful because we start with y prime plus p of x times y equals q of x. Both sides we integrate, both sides we multiply by the integrating factor, right? Which I said was e to the integral p of x dx. So both sides I multiply, so it's going to be e to the integral p of x dx y prime plus e to the integral p of x dx p of x y equals e to the integral p of x dx q of x. So it's a lot to write, but what this is, and I'm sure your teacher said this, is that this is just a product rule differentiation that happened here, right? Because it's a product rule differentiation of this e to the p of x dx times y. Because if you take the derivative of this, right, derivative of the first one is e to the integral p of x dx times the derivative of the inside, which is p of x, right, plus the first one times the derivative of the second one. Oh, look, that's in just a slightly separate, oh, sorry, I forgot to put a y there. So it's the derivative of the first one times the second one, the first one times the derivative of the second one. And that's exactly what we have right here, just in different order, but that's exactly what we have, right? So that's why this integrating factor, this specific one, is useful here, because it puts this in a form where it's like we're taking the derivative, right? So why is that useful? Well, it means that, in fact, I'll just erase this all. It means that when I integrate both sides here, I don't even have to think about this side. The integral, right? So if I integrate both sides here with respect to x, yes, I think both sides with respect to x. Yep. And I'll write that on another line here. So the integral of e to the integral p of x dx y prime plus e to the integral p of x dx p of x y dx equals integral e to the integral p of x dx q of x dx. So just integrate both sides with respect to x. This is just that. This is just that. I just put an integral around it, right? Well, the left side, it looks complicated, but we don't even have to think about it. It's e to the integral p of x dx times y equals, and now the left side, the right side, I keep saying the wrong left and right today for some reason. Integral p of x dx, integral of e to the integral p of x dx times q of x dx, and we're one step away from having our final solution, which is y equals 1 over e to the integral p of x dx times the integral. I'll just copy and paste it, times this integral. And there's our solution. So that will work for any linear differential equation. This is the solution. This formula right here. So really, you could just plug it into that if you wanted to. I really don't see why not, honestly, unless it's somehow confusing. As long as you know where the formula came from, that's always good to know. But other than that, go for it. So here, I'll start with an example. So if this will let me. No, it will not let me. Okay. There we go. Okay. Okay. So actually, I'll start with a harder example. Let me find a harder example here. And again, anybody send me problems? Okay, let's do this one. X plus 2 y prime equals 3x plus y. Okay, so this is our example from lecture. Okay, so this is a linear differential equation because it is linear and first order, right? Because I can write it in the form that we said, which was, just take 2 steps here. So the form again was y prime plus p of x, y equals q of x. Right, so it'll take just 2 steps here. Y equals 3x. So y prime equals negative, no, not equals, minus 1 over x plus 2. Y equals 3x over x plus 2. And now it's in the form. So let's just plug it. I mean, it's good to get your integrating factors separately, right? So I of x, which is e to the integral p of x dx, which is e to the integral p of x is negative 1 over x plus 2 dx, which is e to the negative ln absolute value x plus 2. Okay. That's that. And this is going to be negative go out, so it's going to be absolute value of x plus 2 to the power of negative 1. Yes, and I have a feeling we're just, for some reason, allowed to drop the absolute value. Yeah, we are just allowed to drop the absolute value. Why? I don't know. I don't know why we're allowed to drop the absolute value, but we are. Anybody got an idea here why we're allowed to drop the absolute value? I cannot. Yeah, I don't know. But we just are. So it's 1 over x plus 2. So that part always confuses me when we're allowed
because there's no, e can't be negative. So, like, there's no point.
But this value could be, right? Couldn't that value be negative?
Yeah, but that's like e to the power of like whatever, so that can't be negative. Okay. So yeah. That's what my jet said at least.
Okay, sure. Yeah. Okay, so then we'll go with that. Yeah. So this this quantity, because it's e to that power. Since if this is equal to e to the negative ln absolute value x plus 2, yeah, this can't be negative, so this can't be negative. Is this equal? Hold on. Yes, that is equal, because that's how I got from step to step. Yeah. So if this can't be negative, then this also can't be negative. So that's why. Okay. I will go with that. That's good. So now that's our integrating factor. Well, we can just go for it now. So either just use it as a formula. I'll go through the steps without just using it as a formula, but you could just use it as a formula. So it's going to multiply both sides by this integrating factor. It's going to be 1 over x plus 2 y prime minus 1 over x plus 2 squared y equals 3x over x plus 2 squared. Again, that left side, if I now integrate both of them with respect to x, this is just going to be y over x plus 2 equals, and now we just need the integral of that thing. So the integral of that is just going to be, I can of course move a 3 out, so I'll move the 3 out. So x over x plus 2 squared. Can I say dx? Can I say this? Can I say u equals x plus 2, x equals u minus 2, du equals dx? So this would be y over x plus 2, 3 times the integral of u minus 2 over u squared. Yes, I can say this. Du, because this is y over x plus 2 equals 3 integral u over u squared du minus 2 integral 1 over u squared du. Y over x plus 2 equals 3. This is going to be u 1 over u. It's going to be ln absolute value u minus 2. 1 over u squared is add 1 to the exponent, so it's -1. So negative 1 over u plus c. And we said u was x plus 2. So y over x plus 2 equals 3 ln absolute value x plus 2 plus 2 over x plus 2 plus c. Y equals x plus 2 times 3. I'll move the 3 to the front. So 3 x plus 2 ln absolute value x plus 2 plus 2 plus c. So plus c. And oh, you know what? Actually, no. Sorry, that was wrong. The end there was wrong. So since I'm multiplying both sides not by a constant, I'm multiplying both sides by a function of x, I do actually have to multiply it onto the c here. So this is going to be 2. That's just going to be 2, and this is going to be c times x plus 2. So in this case, you do have to multiply because, again, this is a function of x. This isn't just some random constant anymore. It's a function of x. So yeah, you need that there. Oh, and for some reason it's 6. Did I just do addition wrong? Wait, what? Oh, I didn't multiply by 3, did I? Yes, so this should be a 6 here. So that should be a 6 there. So that should be a 6 there. So that should be a 6 there. Yeah, there you go. Okay, and that's our solution. So did that make sense? Hopefully.
Yeah, can you do that? Go through the steps. Also, I think someone's trying to say something. We can't really hear them.
I can't tell, yeah. Is someone trying to say something? Oh, maybe not. I think someone has some sort of TV on. Okay, I think we're okay. Okay, so everybody check if they're muted. There's some people who are
unmuted. The steps, because some of it kind of missed me, honestly, especially with the changing it from the 1 over x plus 2 y prime to the next thing. I know it's the formula, but I still, like, yeah, and like I know it's the formula, but it still missed me, like the integration of 1 over x.
Yeah, I should write some. Oh, integration of
this part here right now. Yeah, I know it's a formula, but like it still missed me. Yeah.
Yeah. Well, so you can, right? If you take the derivative of this, you would get this up here, right? If you take the derivative, right? So derivative of the first one times the second one, you'd get this, plus the first one times the derivative of the second one. Right? Sorry, let me just be clear. This is a product rule that I'm doing, like that.
Yeah.
Right?
Oh, yeah.
Right? So that would be, and you'd get this up here. And so I can see that just by saying, okay, well, the two things that aren't the derivative. So this isn't the derivative and this isn't the derivative. Multiply those two things together. Right? This is the derivative of something. It's kind of harder to tell that case that that's the derivative, but you can definitely tell that this one isn't the derivative of something. Right? At least not something we're working with. So that's what I combine. Y and 1 over x plus 2. So it's y over x plus 2. So the two non-derivative things is what I combine here.
Okay.
Right. And then the other side is just integrating this. Right. So I can put in general in the steps is, okay, so the steps would be write in standard form, right, which is y prime plus p of x y equals q of x, right? And then our next one thing I would do, okay, so if you're doing all the steps and not just using the formula, right, you would do solve for I of x equals e to the integral p of x dx, right? And then multiply both sides by I of x, okay, the integrating factor, and then 4 is simplify and solve for y. Let's really simplify and solve for y. And solve for y. And the simplify part, right, is left side, I'll just note here, left side is product rule. Product rule. Yeah, let's call it that. Left side is product rule. Right? So that's why that's applying this, going from here to here, right? This is the product rule. This is the result of a product rule. So this is what the product rule was applied to get backwards there. So that's why it's easy to integrate this, because you don't have to actually think about integrating it. You just see that it's a product rule and then go for it.
Where's the ix equal e to the integration of px? That's what you just did.
That's here. That's this. This is my step number 2 here. This is my step number 1. This is my step number 3. This is my step number 4.
Sorry, what's I again? What's I of x?
I of x is always exactly this. E to the integral p of x dx. And p of x is your middle function.
Okay.
Right, so we simplify.
Alright, thanks, bro.
Yeah, no problem. No problem. Yeah. Okay, so let's try another one. Let's do an initial value one, hopefully. Yes. It's too simple. Let's see this one. Okay, this one looks like it takes a second. So this one is an example from lecture. So x y prime equals y plus 2x ln x. I thought that's it. I spoke like I was going to continue, but no. Y of 1 equals 5. That's our initial value. So first step for this one is write everything in standard form. So x y prime equals, I always write an equals there for some reason, negative y, not equals, minus y, equals 2x ln x. Oops, someone took a deep breath. That one. Okay. Hopefully they can mute their microphone. So here, to integrate this, we do... to solve this, to solve for y here, we do our method, right? Which is getting the integration factor, which is e to the integral p of x. In this case, dx. In this case, it's just negative 1. E to the integral negative 1 dx, right? Which is e to the negative x. So equals e to the negative x. And you don't have to worry about a plus c up here. We just choose c equals 0 for that integral. So yeah. Multiply both sides by this. And so we get e to the negative x.
Isn't I thought, you have to take the x away from the y prime.
Yes, you're right. You're right. Yes, you are right. So this is 1 over x, and this is just 2 ln x. You're right. So this would be negative 1 over x. So this would be negative ln absolute value x. Thank you. Yes, that's right. So this, again... What'd you say, sorry?
So just negative x?
Negative, it would, no, careful, it would be 1 over x. it'd be 1 over x. Because look, it's going to be e to the ln absolute value x to the negative 1. Right? Which is absolute value x to the negative 1, which is 1 over absolute value x. But we can drop the absolute values because it's equal to this. Right? This and this are equal. This can never be negative, so this can never be negative.
Okay, thank you.
No problem. So that's our integrating factor. So now multiply both sides by it. We get 1 over x y prime minus 1 over x squared y equals 2 ln x over x. Right? Now the left side is just going to be y over x equals 2 ln x over x. And I am missing something. I missed a plus c. Oh no, I don't miss a plus c. Wait, hold on. I didn't. Oh yeah, sorry. This is the integral of this now. No, wait, what? Integral of this. Integral of this. Yes, sorry, I wasn't paying attention. That's not that. So now we have to integrate this. That's what I'm doing. We have to integrate this here. It's not too bad to actually integrate. So I move this out. So that's 2 ln x over x dx. Let me just take a second because I got confused there, so maybe someone else is confused. So this is where we are, right? I rearranged. I got my integrating factor, which was 1 over x. Right, that's over here. I multiply both sides by it and then integrate. So multiply both sides by it here is going to be 1 over x y prime minus 1 over x squared y. Integrate this with respect to x, and then the other side is going to be 2 ln x over x. Integrate with respect to x. The left side simplifies quickly. It's just y over x. And then the right side is the integral of 2 times the integral of ln x over x. So we have to do u equals ln x, du equals 1 over x dx. So this is y over x equals 2 integral u du. Yep. So y over x equals 2u squared over 2 plus c. So y equals ln, so y over x, ln squared x plus c. Y equals x ln squared x plus cx. And we're almost done because we got an initial value. So y of 1 equals 5. Y of 1 equals 5. So 5 equals ln of 1 plus c times 1. Should be clear. 1 times ln of 1. Ln of 1 is 0. So this is 5 equals c. So our final solution is y equals x ln squared x plus 5x. And that's the solution.
Wait, how do you do the integral be up? Up? Is it how do you do that? 1 over x y prime minus, I'm confused about the integral.
This you don't have to do the integral. This, you're doing the integral, but you don't have to think about it. This is the product rule, right? This is the product rule. So you always just take this thing, multiply it with this thing, right? The two non-derivative things that are here, right? And multiply them together. And you can check. If you take the derivative of this, you're going to get that thing inside the integral there. If you take the derivative of this, you'll get the thing inside the integral. So that this is correct. This is the integral, like this.
Because one of them is well, how do you know it's product rule? Do you just recognize it?
Yeah, that's the whole trick. That's the whole trick. That'll always be the case for linear differential equations. That's why we choose this specific integrating factor, right? We choose this integrating factor so it works. So that this happens, that it's a product rule here. That's why we choose it.
Okay, thank you.
No problem. So yeah, so always look at the two non-derivative things in here. So 1 over x is not a derivative. Y prime is a derivative. Negative 1 over x squared is the derivative of that, and then y is not a derivative. So we choose 1 over x times y, which is y over x, equals the derivative of the right side. Sorry, the integral of the right side, which you have to actually calculate. But yeah. Okay, that's a good question. Let's see what else I have here. think this might be...
Could you scroll down a bit?
Yes. Is that good?
Yeah, that's probably fine. Thank you.
Okay. The last question I have is a word problem, but I have a feeling we're not gonna have a word problem because enough. I don't know. Yeah, I don't know if there's any good reason for that exactly because, well, no, there's a good reason. A teacher said we won't have word problems, so there's a good reason. But yes, dude, am I worried still that we might have a word problem? Yes.
So I have a question.
Yes.
Like, scroll up a little bit.
Huh?
Could you scroll up? Yeah. So you know when you're taking like the integral, right?
Mm-hmm.
Isn't there like a formula you can use or something?
For
I wasn't. Yeah.
Oh, like for this whole part, this whole part here.
Yeah.
All this.
Yeah.
Yes. There is the formula which I showed at the start, and let's try it with the formula. Okay, so we have this is our differential equation. This is our differential equation, and it's in the right. Oops. And it's in the right form too. Wow, why is it going up there? And so we can just use the formula, which I said was, if I can remember properly. Come on. Okay, gotta just OneNote needs a restart every once in a while. Every time I select something, not every time, but a lot of the times when I select something, it screws up. So this is 1 over e to the integral p of x times the integral of e to the integral p of x dx. Sorry, I should say dx here. Q of x dx. So yes, we can just do this. Let's just try it and let's see what happens. So this is our p of x. This is our q of x. So this is y equals 1 over the integral e to the integral negative 1 over x dx. I'll write this bigger. Y equals 1 over e to the integral negative 1 over x dx times the integral of e to the integral negative 1 over x dx times 2 ln x dx. Right, so this is, okay, let's see if it works. Y equals the integral of this integral, which is our integrating factor, is just oh wait, hold on, negative 1 over x. Yeah, no, this is just going to be negative ln absolute value x. Hold on, how is it negative ln absolute value x? Okay, let's just see what happens. Let's just keep going. Times the integral of negative ln absolute value x times 2. I'll move the 2 to the front, all the way to the front actually. So negative 2, and I'll move that negative out too, so it's gonna be positive, right? Ln x dx. Wait, hold on. What? Integral?
Isn't it?
Oh, it's e. Sorry. Yeah. I screwed this up. Yeah.
Isn't it? Aren't you gonna get e to the natural log of this, and then you raise it to the negative 1, so you get 1 over.
So this should be e 1 over e to the ln of the absolute value of x.
Yeah.
Negative ln absolute value of x. Right. Integral e to the negative ln absolute value of x. Right, times 2 ln x dx. Okay, now this is y equals e to the ln absolute value of x integral. This is e to the ln absolute value of x is just, and we'll just call it x, so no absolute value either. So 2 ln x over x dx, and this is now y equals x integral 2 ln x over x, I'll move the 2 to the front, dx. And I can just do the u sub here now, right? So this is y equals 2x u equals ln x du equals 1 over x dx integral u du, y equals 2x u squared over 2 for 2 plus c, y equals x ln squared x plus c. Yeah, hold on. No, this doesn't work because I lost my... Oh, no. Yeah, I jumped the gun a little bit here. Sorry. This... Wow, sorry. I'm mixing things up here. I will not move the 2 to the front. I will not move the 2 to the front. Okay, the x is still on the outside. There. I'll recap this because I kind of screwed this up. So this is going to be x ln squared x plus cx. There you go. So that is correct now. So let me say again what I did. This is our formula. I plug in the formula. Integral of -1 over x dx is negative ln x. So I put that in. That's e to the negative ln x, e to the negative ln x. Right? So since this is 1 over e to the negative ln x, it's just going to be e to the x. Sorry, e to the ln x. Maybe I need more sleep. And then here it's e to the negative ln x, so that's 1 over x. So it's 2 ln x over x. This turns into just x here, and I don't move the 2 to the front because that confuses everything. So just integrate this now. Integrate this using a u sub. So it goes down like this. 2's cancel. And then multiply the x through. And then we just apply our initial condition, but we'll get a 5 no matter what because it's the same thing. So ln squared x plus 5x is the answer again. Notice that was, at least for me, that caused more confusion than just doing it normally. So you can't just use this formula. What'd you say?
It's pretty good. It's pretty good. Like the fact that it actually turns out to be the same. I feel like because you just like try to skip some steps, you confused it.
Yes, yeah. So if the formula works for you, just use the formula. It will get you the same answer.
Oh, okay. So it's just personal preference. So yeah. I was just wondering that. Yeah. Okay.
Yeah. So I would do it without the formula. Just because again, like I just confused myself a million times here, so I feel like I would rather do it without the formula. But yeah, you can. And if you want a nice copy of the formula, it's in my notes, so you can go to homework help and see it there. Where is it? Here. Right. That's the formula. But yeah. Okay, so that is the linear differential equations. Now let's do some difficult problems I can find, I guess. Maybe we'll do that lab problem someone suggested, number 4. Like question number 4.
But I think that's just because I made a mistake. I think it should be number 4 if I remember.
Let's give it a try. But yeah, anybody can
but
suggest.
You can just look at anyone.
Mm-hmm.
Yeah.
So lab number. How do I get just the lab questions? There you go. Lab number 4. Lab number 4.
That's obviously like more difficult. I think you can pinpoint it. I don't remember that.
Sorry, can you say that again? You cut out there at the start, at the beginning of your sentence.
Oh, sorry. I'm saying if it's not number 4, because I don't remember if number 4 is a correct one. Just I feel like one's a bit more difficult, like visibly, like looking more difficult. That's the one I'm talking about.
Yeah. Okay. Yeah, I'll show you on the screen. I'll show you. This is number 4. Looks kind of complicated.
I think that was the one. It was either number 3, but yeah, I think just try that.
Number 3 looks like it's going to be an integration by parts one, but I don't know.
Yeah,
we'll see. Okay, so yeah, let's do number 4 here. So this is lab number 4. Lab number 4, question number 4. So that's y prime equals -2x tan y. Oh, this is a separable differential equation. So y of 0 equals pi over 2. There's our initial condition. So again, separable. Our f of x is -2x. Our g of y is tan of y. So I can write this as the integral of cotan of y dy equals the integral of negative 2x dx. So hopefully everybody can take a second, and if this doesn't make sense, why it's
how did you cotangent?
Because it's 1 over tan.
Yeah, how did you get
1 over tan? It's going to be 1 over tan of y, and that is just cotangent. Right, because again, the formula is 1 over g of y dy equals integral f of x dx.
Yeah, I don't think I can see your screen, bro.
You can't see my screen? Oh.
No.
Oh, yeah.
You got disconnected. Yeah, I thought it was me. I was just like, I think it's you, Adam.
Okay, anybody else? What do you see on the screen right now?
Just the call. That's it.
Oh.
Yeah, your stream just ended.
Your stream had ended, bro.
Oh, okay. I don't know why. I didn't click that, but okay. I'll just
Yeah.
Let's see. Hopefully that didn't happen when did that happen? Did you just see it? Or?
Just a second ago.
Literally
midway
just a
in
sec.
explanation.
Yeah. Okay. There. Is it back now?
Yeah.
Okay.
No, we're
You're good now.
So here's the question. So this is where I am. Cotan y dy. This is where I am now, right here. And it's cotan because the formula is 1 over g of y. So g of y was tan of y, so it's 1 over tan of y, which is cotan of y.
Yeah, was that some rule from last time or something?
What?
1 over g of y dy? Or I'm mixing it up.
Sorry,
that's 1 over g of y.
Is that a rule from what?
Yeah, the 1 over g of y dy equal to fx. Or is that just basic?
That's how you solve a separable differential equation. So if you have a differential equation in the form g prime equals
yeah I'm tired.
Right, so
yeah,
you go. I'll write it again, but g of y dy equals integral f of x dx, and then you just solve for y. You integrate and solve for y.
I can't forget for a second. Sorry.
Don't worry. Integral of cotan. Hope it's on this sheet. It is not. I think it's cotan ln absolute value or negative ln absolute value cotan something. I could just be making up things. I don't know. It's not on this sheet. Does anybody know it?
I don't see it in the textbook either.
It's ln absolute sine x.
Absolute sine x.
Or wait, I might have
ln absolute value sine x.
Yeah, plus c. Yeah.
Oh, that's it. Plus c. That's it. Okay. Actually, I'll write that in black. But yeah, ln absolute value sine. So sine y in this case. Ln absolute value sine y.
Yeah.
Equals negative 2x squared over 2 plus c. Like that. Now I will. This will cancel, of course. So negative 2x squared. E to the power of both sides. So absolute value of sine y equals e to the negative x squared plus c. Absolute. I can get rid of the absolute value because e to something is never negative. So sine y equals e to the c, e to the negative x squared. And so y equals sine inverse of e to the c, e to the negative x squared. And our initial value was y of 0 equals pi over 2. So pi over 2 equals sine inverse. Well, you know what? I'll do it from this step here. So sine of pi over 2 equals e to the c. Yeah, it was y of 0. Yeah, e to the 0. E to the 0 is 1. So sine of pi over 2 is 1, I think. I think it's 1. So 1 equals e to the c. So y equals sine inverse of e to the negative x squared is our answer. Maybe someone check that. I'll just do it on my calculator here. Sine of pi over 2. Yes, it's 1. So there's our solution.
Did you get an X from? Just on the. Oh yeah, never mind.
Good.
Let's just keep this in.
Okay, so there's that question. Anything else from this lab that anybody wants me to do?
Now the parts.
Which one? Sorry.
Number three.
Number three.
Parts. Because
Okay,
the rest are pretty like.
The rest don't seem too bad. Yep, they seem okay after this.
Yeah, I think the second to last one is also integration by parts, but just a point too, I think.
So this is number 3 is y prime equals y squared e to the x sine 3x and y of 0 equals 1. Yeah. So now, from here, this is a separable differential equation. So to integrate this is going to be, to solve this, we're going to integrate like this. So it's going to be y to the negative 2 dy equals integral e to the x sine 3x dx. Okay, so the left side integrates pretty nicely. It's just add 1 to the exponent, divide by the new one. So it's going to be negative 1 over y equals, and now this right here. Okay, so now let's figure out what that, I'm going to do it on the side here. Integral of e to the x sine 3x dx. So I'm going to do a integration by parts. So u equals e to the x, or actually I'll say u equals sine 3x. dv equals e to the x. du equals 3 cos 3x. V equals e to the x. So this is equal to e to the x sine 3x minus the integral of 3 e to the x cos 3x dx. I'm going to do another u substitution, another integration by parts. So u equals cos 3x, dv equals e to the x, du equals negative 3 sine 3x, sine 3x, v equals e to the x. So this is going to be e to the x sine 3x minus 3 times e to the x cos. Actually, I'll multiply the minus 3 in right away. So minus 3 e to the x cos 3x. Minus or plus 3 integral minus 3 sine 3x e to the x dx. Move that minus 3 to the front, so it's minus 9. This is equal to the integral e to the x of sine, integral of e to the x sine 3x dx. So add 9 integral sine 3x e to the x dx on both sides. So 10 integral e to the x sine 3x dx equals e to the x sine 3x minus 3 e to the x cos 3x, and we get our solution by just dividing by 10 on both sides. Okay, so now negative 1 over y is equal to that. E to the x, I don't have a plus, well, I'll add a plus cf, I guess I'll just put it here, plus c. Sine 3x over, I'll say 1 over 10 times this. Minus 3 over 10 e to the x cos 3x plus c. I will just flip this around. Yeah, I can, can't I? Or I can put, no, you know what, I will put this all under one fraction. This is all one fraction. Well, I can put the c in there too, it doesn't matter. Okay. Yeah, so then this is going to be negative, yeah, okay, I'll be more clear with what I'm doing. Multiply both sides by y, and multiply both sides by y, we get negative 1 equals y times this. What'd you say? Did someone say something?
So why would it be better to just? I mean, it's the same thing. They get into yeah. So I think you'd better if you just flipped it.
Yeah, and then now I'm gonna flip it. Right now it's gonna be so multiply both sides by 10 over e to the x sine 3x minus 3 to the x cos 3x plus c. So it's negative 10 over e to the x sine 3x minus 3 e to the x cos 3x plus c equals y. And one thing you will see very often is taking out the negative to the front and then applying it to the bottom. So this will become 10 over, and you just flip the position of the two things. Just apply the negative to the bottom. That's all you're doing. Cos 3x minus e to the x. Just to be clear, that's minus e to the x sine 3x plus c equals y. Like that. Okay, and then we have an initial condition.
Minus c.
Y is here. You don't have to.
I mean, it doesn't matter. It doesn't matter. Yeah.
Yeah. Right. So, y of 0 equals 1. So it's going to be 10 over 3e to the. Well, I'm not even going to write everything. So, yeah, you know what? I will write everything. 3e to the 0 cos of 0 minus e to the 0 sine of 0 plus c equals y. Sorry, equals 1. So we just solve for c now. E to the 0, that's both 1. Cos of 0 is 1. And sine of 0 is 0. So it's 10 over 3 plus c equals 1. Right? So 10 equals 3 plus c. C equals 7. So our final answer is y equals 10 over 3 e to the x cos 3x minus e to the x sine 3x plus 7. And that's the final answer.
Solutions? Oh, is it just a check?
What, check the solutions? Is that what you said?
Yeah, like, are the lab solutions out? Does it?
No, they're not out yet. No, they're not out yet.
Oh, okay.
Although I probably can watch the video, the lab video.
Yeah, that's okay. Coins.
Okay, so any other ones from this lab to do that anyone wants me to do? Yes, one person asked me for a textbook question, so I will do that textbook question. Okay, I'll do the textbook question that this person asked me for next. And I'll be finishing up soon. So, last couple questions. This Calculus 2, that's the textbook. And it was question 229, I think. 229. Oh, you know what? I think I just did that question. Literally, that was the last question I did. I didn't finish all the practice questions for this, which is not usual for me. I usually do all the practice questions, but did not finish all of them. 229. Yes, so 229 from the textbook. So that is sine of x y prime equals y plus 2x. That's it. No initial conditions. Nope. So just in general, solve for this. So we have to write this in the correct form. So this is going to be y prime, or sine of x, y prime minus y equals 2x. Right. So y prime minus 1 over sine x times y equals 2x over sine x. Okay. Now this is just cosecant x, right? And this is also cosecant, so I'll just say 2x cosecant x. And now it's in the right form, so we can just use just the method for it, right? Which is first find the integrating factor, which is the e to the integral negative cosecant x dx, which is negative the integral. And I need the integral of cosecant is not something I know. I don't have cosecant. It's like something minus something. Does anybody have this one?
Integral negative ln absolute cosecant plus cotangent x.
Cosecant x plus cotangent x. That's right. That's good. Okay. Okay. Thank you.
No. It would have if you're integrating negative cosecant. What were you integrating? Sorry.
We're integrating negative cosecant. Yeah.
Okay, then it would be a positive because the actual integration is secant
that's true,
is negative ln.
Yes. Yeah. So then this is just going to be, and again we can forget about the absolute values because it's e to some power. So cosecant x plus cotan x. That's our integrating factor. So multiply both sides by it. We're gonna get cosecant x plus cotan x y prime minus cosecant x plus cotan x cosecant x y equals 2x cosecant x times cosecant, I'm running out of space, I'll write on the next line, times cosecant x plus cotan x, right? And then from here, the left side, well, we integrate both sides with respect to x. Right, so dx. So the left side is just going to be cosecant x plus cotan x times y, which is equal to the integral, or 2 times the integral of x cosecant x times cosecant x plus cotan x dx. Okay. I will.
Wait, didn't you?
Yeah.
Didn't you forget the c in the exponent?
Oh, like here there should be a plus c.
Like in the exponent after the ln cosecant x plus cot x.
Yeah, like so. Oh, my face is probably in the way. Like here, the plus c up here.
Yeah, right there.
Right. Yeah, you don't have to worry about a plus c for this integral. You can just say c equals 0. You just need a antiderivative for that one.
All right.
So the c comes from the actual integration that you're doing here. There's no plus c. Okay. So let me just separate that. Okay, so now I will multiply. So cosecant, you know what to say, equals 2 integral x cosecant squared x plus cosecant cotan x dx. That was the wrong decision to do. So it looks like I'm going to have to do a... How do you integrate that? So it looks like that... Looks like the derivative of cosecant x plus cotan x. I think the answer is... No, but it's an x in the front. Yeah, actually no. We can still do that. So we're going to just do a what is it called now? What I was just doing, the first thing.
Can you repeat that? I didn't hear. I think you just said.
Yeah, I'll explain it in just 1 second what I'm saying. I'm going to do a... Wow. Oh my god. The integration by parts. We're going to do an integration by parts here, which is usually when you see an x like that, it's good to do an integration by parts. So this is going to be, I'm going to choose u equals x, dv equals cosecant x times cosecant x plus cotan x dx. Du equals dx, and now what's v? Well, I don't know what the integral of that is, but I look back over here, and I'm going to get a hint from this section, right? Because remember, this is in the form f of x, y, g, I'll say it. This is in the form, f g prime g f prime g. Right? Let me just be completely clear here. That's that. That's that. That's that. Oops. That's that. Oh, wait, actually, negative. That's that. So, I don't know what this antiderivative is, but I can see that the derivative of cosecant x plus cotan x is negative cosecant x plus cotan x cosecant x, which is what I have. So, looks like the antiderivative is negative cosecant x plus cotan x. So I just used a little bit of reasoning from the question here.
Yeah, I was actually just checking that. I'm not even sure because I just choose a symbol up. I was just like, it's a whole different thing. I was looking at it for a while now. It's like natural log of tan plus natural log of sine. So it's
that's
like,
the derivative.
Unless, yeah, unless they rewrite it somehow to make it the same. But yeah, that's what I saw.
So you got natural log of a tan plus natural log of sine, right? That's what you said?
That's what I saw. Tan over 2.
So this is ln of tan x times sine x.
Yeah.
Which is ln absolute value sine squared x over cos x. How to get rid of the ln though?
It's x over 2 though. That's what it says.
Where's x over 2?
Tan in bracket x over 2.
Oh,
so natural log of all of that, and it's absolute valued. But I guess you can.
Yeah. Okay, I don't know how to change it, but I think this should be still.
Yeah,
should still be right.
Should be.
It should still be right.
Maybe.
Maybe let's look at what Wolfram does and then do it from there.
I didn't try it there, actually. Good job.
Let's see. Let's see. Yeah, it gives me what I was expecting. Derivative of cosecant x plus cotan x is negative cosecant times cotan plus cosecant. Let's see, alternate forms. Is there alternate? So it usually gives me alternate forms. That's right. No.
Silverlab must have bugged out on that one.
I don't know. Yeah, okay. But so we're good. We're good. Maybe it's the same. I don't know. I can't see how to get to the same, but yeah, probably is the same. So anyways, we're good then. We're good for this. So then I can just do, let me make sure I did that right. We want the positive thing there. Yeah. So this is going to be 2 times negative x cosecant x plus cotan x, okay, minus integral of, plus cosecant x plus cotan x dx. Yeah. Close bracket. Well, now we have to find the integral of that, which doesn't look good. So, yeah. Okay. I'll write this again. So, 2 negative, I'll move the negative 2 in. So, negative 2x cosecant x plus cotan x plus 2 integral cosecant x plus cotan x dx. I do not know how to integrate that. Cosecant. Okay, well, let's see if I can do anything. So cosecant x plus cotan x. Cosecant is 1 over sine x. I'll leave off the x's now. So 1 over sine. Cotan is cos over sine. So I'm adding these. So it would be 1 plus cos over sine. And not 1 plus cos squared or none of that. So that doesn't really help us that much. Can I integrate this? Yes, I can integrate that. Okay, that's not bad. negative 2x cosecant x plus cotan x plus 2 integral 1 plus cos x over sine x dx. Oh, no, wait, hold
on. Can you do that individually? Because we have the integral of cosecant and the integral of cotangent.
Yeah, we can separate this. Yeah, we can separate this. So this is going to be the integral of 1 over sine. So it's going to be cosecant x plus cos over sine. Cos x over sine x. I guess in both cases we could have just actually, this is kind of useless because we could have just looked it up. Maybe I have it for both of them here. Yeah,
I can tell you. You even use one just now. Cosecant is the negative natural log of cosecant x plus.
Hold on, I'm gonna write it here.
Sorry.
Right here. Okay, so yeah, you know what? Forget about all this. Yes, this would work in figuring it out, but not really helpful. Just know what the derivatives are of these things. So cosecant, you said, was
negative natural log of cosecant x plus cotangent x plus c and what?
And the other one?
And then
integral of cotan.
Just natural log of sine x. Yeah, absolutely, both of them. Yeah.
Of sine x plus c.
Yeah.
Okay, so cosecant x plus cotan x y equals that. Okay, here is our our equation. We just have to solve for y now, right? So it's just going to be y equals negative 2x minus 2 ln I could combine those. I will combine those. Ln absolute value. In fact, I'll factor out the 2. So plus 2 times negative ln absolute value cosecant x plus cotan x plus ln absolute value sine x close bracket plus c. This is all over cosecant x plus cotan x. That's it. There you go. And just to be a little more clear, negative 2x plus 2 ln absolute value sine x over cosecant x plus cotan x all over cosecant x plus cotan x plus c. Just combine those up there. And that's it. Okay, do we have an initial value? No, we don't have an initial value. Sorry, initial value. Probably could factor out the 2. So 2 ln absolute value sine x over cosecant x plus cotan x over cosecant x plus cotan x minus x plus c. Yeah. And there's that. Oh, this would actually be c. No, the c has to stay in. The c's in there with it. Plus c's in there. But minus x is here. The plus c's over there. Because the c also has to be divided by cosecant cotan. Okay, but there's that question done. Hopefully that's the answer. The person who sent it to me. Hopefully, or I'll just check in the textbook. But most likely, this will just be the question is written a different way. But let's see. We said 2. This is chapter 4, right? No, yeah. Said 229. Yeah, well, different for sure.
Different or rework different?
Yeah, honestly, I'm gonna put this into Wolfram and see what Wolfram does. So that's probably our last question for today. Okay, that's our. I'll just check this answer and then that'll be it for today, unless there's any pressing questions. But I mean, anyone can ask me just small questions here and there, of course. Anybody can also message me at any time. Let me know if you have questions. I'm just checking on Wolfram for this one.
Yeah, Adam.
Yeah.
The notes that you have is that your typed notes or is that like?
No, those are my typed
notes. Notes. Oh, dude, that's just a different level. Good job.
Yeah, thank you. I typed them in LaTeX.
Let's see. All right, cool.
Okay, yeah. Wolfram says the same thing as what we do. But let's see. Alternate forms. No, that's the alternate form of the thing. Okay, I'll go through this. Yeah?
I can check it on Slater, maybe. Is there like door solutions there too?
There too. Yeah, let's see.
Yeah, I'll check there.
Oh. Is that Oh, that's strange.
Oh, what number was it? 229, right?
Okay, so right off the bat, Wolfram, is that true? One.
Something. What Wolfram did?
Sorry, you
just use. Yeah.
Wolfram right away has a different integrating factor.
Oh yeah.
I'm just gonna try something.
No, isn't that what we had? Negative.
So their integrating factor is cotan of x over 2. We have cosecant x plus cotan x. But it's not different. They integrated the same thing. It's just they got a different integral on the top there.
Well, unless Professor's table was wrong, which I don't, then I don't know what they did differently.
Yeah. No, I think it should be good. What was it? Cotan x over 2? Cotan x over 2. 1 over tan. Okay, so that's just an identity then. That's just an identity. This is equal to cotan of x over 2. I don't know why, but it is. So you probably use some sort of double angle or half angle formulas to figure that out.
I sent the Slater thing in homework help.
Okay, let's see.
I think it's kind of different.
Wait, integral of 2x. Wait, why did they not? You don't need. Oh, you already don't need an integrating factor? That's not true. This is a different question.
Is it?
Yeah, it's a different question.
Yeah.
Yeah.
What was the reason? Because obviously the left-hand side is the differentiation.
Send me right back to the top. Yeah. So what they